螺旋槳令飛機有4個 left turning tendencies， 分別係 torque reaction from engine and propeller, corkscrewing effect of the slipstream, gyroscopic action of the propeller, asymmetric loading of the propeller， 簡稱 P factor。首先我哋由第一個 torque reaction from engine and propeller 開始講起。torque reaction 係其中一個最明顯嘅 left turning tendencies。佢喺飛機速度較低同飛機引擎嘅 power 開到好高嘅時候係最為明顯嘅。咁從駕駛艙入邊嘅角度望出去，美國製造嘅飛機嘅螺旋槳係向右旋轉。雖然飛機引擎嘅馬力、螺旋槳嘅尺寸同飛機嘅尺寸存在差異，但飛機引擎施加俾螺旋槳嘅 torque 喺任何情況下都係好大嘅。torque reaction 嘅原理同 Newton's third law 牛頓第三定律有關。Newton's third law 指嘅係如果物體 A 對物體 B 施加作用力，英文 action force， 咁物體 B 一定會同時對物體 A 施加大小相等、方向相反嘅力，英文叫 reaction force。呢條影片示範咗 Newton's third law 嘅原理。因此，螺旋槳向右旋轉緊嘅時候，一個大小相等嘅 reaction force 會令飛機向左 roll。從圖片中可以睇得出，白色箭嘴係螺旋槳旋轉嘅方向，而藍色箭嘴係 reaction force 嘅方向。正正因為咁，飛機先會向左 roll。輪到第二個因素 corkscrewing effect of the slipstream。 corkscrewing 中文叫做螺旋形。螺旋槳嘅高速旋轉令 slipstream 螺旋形咁向後流動。當螺旋槳轉得好快同飛機好慢嘅時候，例如起飛嘅時候， slipstream 對飛機嘅影響就會非常明顯。佢會喺飛機嘅 vertical stabilizer 表面施加強大嘅力。當螺旋形旋轉嘅 slipstream 撞擊 vertical stabilizer 嘅時候，會導致飛機向左邊喐。slipstream 越緊湊，撞擊力就越突出。但係隨住速度嘅增加，螺旋形旋轉嘅 slipstream 會拉長並且減少對飛機嘅影響。嚟到第三個 gyroscopic action of the propeller。 喺了解螺旋槳嘅 gyroscopic effects 陀螺效應之前，我哋需要了解陀螺嘅基本原理。陀螺儀嘅所有實際應用都基於 gyroscopic action 嘅兩個特性 rigidity in space 同 precession。 rigidity in space 係指陀螺喺空間中嘅慣性。快速轉動緊嘅陀螺會傾向保持喺原來嘅位置唔喐，就好似依家播放緊嘅 GIF 咁。陀螺轉動緊嘅時候，就算佢企喺條繩上面，佢都唔會跌落嚟。而 precession 係指陀螺轉動嘅時候會有一個90度嘅 resulting force 向出。大家將圖片中嘅輪胎想像成螺旋槳，螺旋槳轉動嘅時候會有一個90度嘅 resulting force。黃色箭嘴向出。依家播放一條示範90度 resulting force 嘅影片俾大家睇下。
The force is down that way, but the torque vector is actually pointing out this way. So the angular momentum of this wheel is being increased in that direction. So the more I apply this torque, the more I increase the angular momentum of the wheel in the direction of the torque. So I'm making this wheel have a very large angular momentum out towards the camera, out towards you. Well, in that case, the bicycle wheel would already have angular momentum this way, and so a torque pushing that way actually swings this angular momentum round that way. Okay, so let me try to get the wheel spinning and make it work. Come on. Oh, look at that. It's rotating as we predicted.
嚟到 precession 會令飛機有 pitching 同 yawing 嘅動作。而因為有 precession 嘅關係 ，yawing 會導致 pitching， pitching 會導致 yawning。依家播放一條示範 precession 係點樣影響 yawning 同 pitching 嘅影片俾大家睇下。
Powered up. Can you hear that? Kind of sounds like a jet engine coming up to speed, doesn't it? The gyroscope's running, and let's check for gyroscopic rigidity in space. So notice I can push on it. The airplane doesn't really want to move. Look at that, I'm pushing on the tail. Doesn't want to change direction. I'm going to pretend I'm pushing stick forward, elevator goes down. See that nose move to the left? Now what happens if I pull stick back, elevator goes up, nose moves to the right. Now what about left rudder? Notice the nose goes up. What about right rudder? Nose goes down.
嚟到最後一個 asymmetric loading of the propeller， 簡稱 P factor。P factor 指嘅係飛機喺 angle of attack 大嘅時候，例如爬升緊嘅時候，右邊向下轉動緊嘅螺旋槳扇葉嘅 angle of attack 比左邊向上轉動緊嘅螺旋槳扇葉嘅 angle of attack 更加高，因此令 center of thrust 從螺旋槳嘅中間位置轉向右邊嘅位置，左右兩邊嘅 thrust 就會唔平衡，右邊嘅 thrust 會比較大，因此會令飛機喐向左邊。呢個 topic 經常會用到一個字，就係 bite 咬嘅意思。我哋幾常會見到網上教材會話向下轉動緊嘅螺旋槳扇葉嘅 bite 會比向上轉動緊嘅螺旋葉扇葉嘅 bite 大。我哋可以將 bite 理解為 angle of attack。bite 大 angle of attack 就大 ，bite 細 angle of attack 就細。就咁用文字解說係幾難理解嘅。睇完接落嚟嘅片呢，希望能夠幫助大家理解。
So, I have capped aircraft to simulate straight and level condition of flight. I am using a scale and vernier calipers to check how big a bite of air the propeller takes. We would assume the relative airflow and ideal conditions like there are no slippage or errors. I have capped the scale behind the right blade of the propeller first, and I am measuring the bite of the propeller. It came to be around 1.5 centimeters on that part of propeller. Now, I am repeating the same process on the left blade. And of course, as the plane is capped straight and level, so the bite of left blade has to be same as the right blade, thus producing equal amount of thrust on both sides of the propeller hub in straight and level flight. Now, to simulate high angle of attack of the airplane, I would lift up the nose a bit and again repeat the process of measuring bite in same way. But this time, the bite of right blade has increased to 2 centimeters. Now let's check that of left blade. Okay, so the bite of the air which left blade would take has reduced to 1 centimeters only. Now, you just have to put simple logic in it.
你或者會疑惑量度 blade bite 嘅距離有啲咩用呢？呢個能夠以畢氏定理解釋。angle of attack 係 coordinate 同 relative wing 嘅夾角。咁 angle of attack 嘅對角線係 left-right blade bite。咁如果 left-right blade bite 嘅長度變長呢 angle of attack 就會變大。如果 left-right blade bite 嘅長度變短 angle of attack 就會變細。right blade bite 嘅長度係2 cm 嘅話呢螺旋槳嘅 coordinate 同 relative wing 形成嘅 angle of attack 就會較大。left blade bite 嘅長度係1 cm 嘅話呢螺旋槳嘅 coordinate 同 relative wing 形成嘅 angle of attack 就會較細。依家播放一條螺旋槳轉動嘅慢動作動畫俾大家睇下。 好，嚟到呢度4個 left turning tendency 嘅因素都解釋完啦。希望呢條影片能夠幫助到大家理解咩係 left turning tendencies。